Can you bring a species back from the dead? And why would you want to anyway? Find out in the latest episode of Catastrophic Science. Back in the 70s, Australia discovered a new species, the gastric brooding frog. This amazing frog actually swallowed its fertilised eggs or newly hatched tadpoles. The stomach then began to function like a uterus, and the tadpoles grew into fully formed frogs. When they were big enough, the mother would projectile vomit them out. Yes, projectile vomit them out. The frog's unique stomach function had scientists wildly excited about the possibilities for modern medicine. But no sooner had it been discovered than it disappeared from the wild. It became extinct in the early 80s, an opportunity lost. An introduced species caused the catastrophe. Chytrid fungus, which lives in its skin, the apparent reason for extinction. Mike, the gastric brooding frog has been extinct for over 30 years. So why all the renewed interest?
Because this is definitely the most extraordinary frog that ever lived anywhere in the world. There is increasing interest in the fact that many animals are becoming extinct in the world. We're losing biodiversity. We need to find some animal that can be demonstrated to be brought back from the dead.
Wow, that sounds like something out of Jurassic Park.
I'd love to think that that's true, but I don't think about it as playing God. I really think about it as playing smart human.
And so how did you obtain a specimen from so long ago?
I went to the person that I knew had last had a colony of these frogs. That was Mike Tyler in the University of Adelaide. And he had, coincidentally, frozen whole gastric brooding frogs in the bottom of his freezer. So we now have a team of experts drawn from all over the world. It's the perfect team we need to carry this project out.
So this project looks at recreating an extinct species using a process called somatic cell nuclear transfer. We have to take a cell from our frog that's been kept in the freezer and put it back into the egg of another Australian frog. Now that Australian frog, we can get those eggs and we have to remove the DNA so it has no DNA in that egg. We then replace it with a cell from our gastric brooding frog. It then interacts with the egg and starts to develop into a tadpole.
So this is actually our host frog species, the great barred frog, where we get our donor eggs from. It's a slow process because as far as we know it only breeds once a year, so we actually have to go out each year and collect these from the wild, and then we induce them with hormones when we actually require the eggs.
Cloning has been done before, famously seen with Dolly the sheep in 1996. They took cells from a sheep and injected them into the egg of the same species of sheep, which produced a clone of the first one. The gastric brooding frog is more challenging, as it uses cells of an extinct frog with the egg of a different species. So how successful have you been?
So there's a global effort to bring back extinct species, but our team is the only team to have brought back and have the embryo divide of an extinct amphibian. That's amazing.
So far the embryos have lived for 3 days, so there's still work to do before reintroducing the gastric brooding frog back into the wild. If successful, the benefits will extend not only to endangered and extinct animals, but also to humans.
Medicine looks at the solutions that nature already has. And so it's quite important that we protect our native amphibians because they have answers, and science simply hasn't got to looking for them yet.